This is the Panzer VIII Maus, the heaviest, fully enclosed, armored fighting vehicle ever built. The Maus was conceived as a mobile fortress, a machine meant to wipe out enemy armor with a single well-placed shot. In this film, we're looking at the one example that survives today, a Porsche-designed prototype that WWII seized by Soviet troops at the end of the war. The Panzer VIII was a super-heavy tank fitted with two cannons mounted next to each other. Its name, Maus, meaning mouse, was chosen deliberately to disguise how enormous the project actually was during its early development. In fighting trim, it weighed close to 189 tons, roughly the same as 3 King Tiger heavy tanks put together, or 6 M4 Shermans. With its main gun facing forward, the vehicle stretched 33 feet 1 inch, or 10.08 meters, from front to back. It measured 12 feet, or 3.67 meters, across and stood just under 12 feet, or 3.63 meters, tall. Measured at the center line, the tracks sat 7 feet 8 inches, or 2.33 meters, apart nearly wide enough to swallow a classic London double-decker bus. I'm David Webb, and you're watching Blue Paw Print. The Maus carried a crew of 6. 2 men worked inside the hull, with the driver on the left and the radio operator seated to his right. The remaining 4 crewed the turret, a commander, a gunner, and a pair of loaders. There was no way to pass between the hull and the turret. The 2 compartments were entirely separate, and the crews could only talk to each other over the intercom. The driver and radio operator climbed into their space through one rectangular hatch cut into the roof. Directly in front of the radio operator's seat, a hatch in the floor served as an emergency exit. His main job was keeping the tank in contact with the outside world through its standard issue, FUG-5 radio set. Unusually for a German tank of this era, the Maus carried no hull machine gun at all. Any opening cut for one would have weakened the frontal plate too much. Instead, the radio operator kept watch over the battlefield through a rotating periscope of his own. The turret crew each had their own individual hatch on the turret roof to climb through. For all its size, the fighting compartment was cramped almost beyond belief. The enormous breeches of the 2 guns, together with the ammunition stored close at hand, left barely any room to move. The commander worked from the rear left of the turret. He had his own rotating periscope, but the space forced him to stand permanently hunched over. That awkward posture kept him clear of the recoil guards whenever the guns went off. And out of the loader's way, as he worked the main gun, he wasn't even given a proper seat. Instead, he braced himself in a kind of suspended sling, and he still had to twist his whole body 90 degrees to one side each time the guns fired. The gunner sat at the front left of the turret. His seat was set further back than the commander's, giving him just enough room to work comfortably. The turret alone tipped the scales at 55 tons, heavier than a complete Super Pershing. It rode on a ring of rollers. 3 large pairs carried its weight, while 6 smaller pairs of guide rollers kept it running true as it swung around. The mounting could even drop the turret down by a few millimeters to seat it firmly against a rubber seal, sealing it watertight for river crossings. The ring itself measured 9 feet 7 inches, or 2.95 meters, across, large enough to house the gun, soak up its recoil, and store ammunition. A 7.5 kilowatt electric motor handled the rotation. It wasn't an especially powerful motor, but it still had 55 tons to shift. Running flat out, it needed 45 seconds to swing the turret through a complete 360-degree turn. Compare that to the T-34, which could do the same in just 14 seconds. A manual crank sat beside the gunner's seat for fine adjustments whenever the electric drive moved too fast for precise aiming. Each full turn of that crank shifted the turret by just 0.58 degrees, meaning a complete rotation by hand would take 621 turns. The main armament was a 128mm Kpfw 55 cannon. It could depress 7 degrees below level and elevate up to 23 degrees above it. The barrel ran roughly 23 feet, or 7,020 millimeters, in length, cut with 40 grooves that spiraled to the right. There was no muzzle brake fitted, so recoil ran long between 2.69 and 3.15 feet, or 820 to 960 millimeters, per shot, absorbed by a pair of cylinders mounted above the barrel, one on either side. The gun used a horizontal sliding breech block that was only quarter automatic. The crew opened it by hand, but it snapped shut on its own once a round was loaded. Ammunition for the 128mm gun came in 2 separate pieces rather than one fixed round. The projectile alone weighed up to 62.4 pounds, or 28.3 kilograms, while the propellant charge in its case added up to another 58.6 pounds, or 26.6 kilograms. As the shell traveled down the rifled barrel, two soft metal bands around its body were cut by the grooves. Those bands did double duty, sealing in the propellant gases behind the shell and setting it spinning for a stable, accurate flight. Muzzle velocity started at 3,084 feet per second, or 940 meters per second, though this was late, are dialed back to 3,035 feet per second, or 925 meters per second, to reduce wear on the barrel. The primary armor-piercing round was known as the 128 mm Panzergrain 43, and it was built up in distinct layers. A thin aerodynamic cap sat right at the tip to smooth its flight, with a blunter, softer cap underneath designed to grip sloped armor rather than skid off it. A fuse was threaded into the base of the shell alongside a colored tracer element, letting the crew watch the round in flight and correct their next shot. This round could knock out any tank the Allies fielded, provided the range was long enough at 3,200 yards, or roughly 3,000 meters. It could still punch through about 6.8 inches, or 173 millimeters, of armor angled at 30 degrees. Against something like a Sherman, that meant the Maus could open fire well before the enemy tank was even close enough to shoot back. The instant the shell broke through, its base fuse set off a bursting charge that scattered fragments through the enemy's crew compartment. The trouble was getting the second shot off, with two-piece ammunition loaded entirely. By hand, projectile first, cartridge second, the gun could only manage 2 or 3 rounds every minute. Sitting alongside the main gun was a secondary 75 mm Kpfw 36 cannon, meant for softer targets that didn't justify using up the heavy 128 mm shells. It fired with less punch than the big gun, but made up for it with a much quicker cyclic rate of 10 to 12 rounds a minute. This weapon was a stretched version of the Kpfw already fitted too early. Panzer IV's the barrel had been lengthened because engineers worried that gases from a shorter barrel might get drawn into the engine and cooling intakes. Both guns shared a single twin cradle hung in trunnion mounts, so they always moved together. The gunner adjusted their elevation using a manual handwheel, and because of the sheer weight involved, turning it took somewhere between 66 and 110 pounds, or 30 to 50 kilograms, of force. For dealing with infantry at close range, a single 7.92 mm MG-34 machine gun was fitted in the turret. Storage for the 128 mm shells was split between 2 locations. 24 rounds sat in racks inside the turret itself, with another 45 tucked away in the hull sponsons, the gap between the inner hull and the outer armor plating. The 75 mm ammunition had its own dedicated stowage, with most of it kept in the hull beneath the rotating platform floor, near the rear wall of the fighting compartment. A further 25 rounds for that gun were held in the turret, positioned to the right of the weapon itself. The 1,000 rounds carried for the machine gun were stored in armored ammunition boxes. To aim both main guns, the gunner used a TWZF-1 periscopic sight offering 10x magnification, far sharper than anything fitted to an Allied tank at the time, capable of precise shots out past 2.5 miles, or roughly 4,023 meters. 2 separate scales on the sight's right side tracked elevation for the 128 mm and 75 mm guns independently. The eyepiece itself never moved. Instead, an internal mirror linked directly to the gun mount tilted along with the barrels, keeping the gunner's eye in a fixed spot for quicker target acquisition and inside 0.75 miles, or about 1,207 meters, the shell traveled fast enough that the gunner could point almost straight at the target, past 1.24 miles, or roughly 2,000 meters, though he had to compensate for the shell's arcing drop. Getting that first shot right depended on knowing the exact range, and a new vertical rangefinder from Zeiss was supposed to solve exactly that problem. The turret was built with mounting brackets already in place on its roof, ready to receive the device, but the rangefinder itself never actually arrived. Without it, the gunner had no choice but to estimate distance using the markings in his sight. Had it been delivered, the rangefinder would have sped up and sharpened aiming, offsetting some of the delay caused by the gun's slow reload. Instead, Engagements took longer to set up, and accuracy dropped off noticeably at long distances. German planners saw the Maus as a breakthrough weapon capable of smashing through even the strongest. Fortified lines, and the intent wasn't just a strong front plate, but roughly equal protection all the way around. The glacis plate measured 7.87 inches, or 200 millimeters, thick, with the side armor coming in at 7.09 inches, or 180 millimeters. The roof carried 4.06 inches, or 103 millimeters, of steel to guard against plunging artillery fire. Up front, the belly plate was 4.09 inches, or 104 millimeters, thick enough to survive a direct hit from a Soviet TM-4 for anti-tank mine. The turret's face carried a massive 9.3 inches, or 236 millimeters, of armor, while its sides and RIR were protected by 8 inches, or 204 millimeters. The weakest point was the turret roof, covered by just 2.4 inches, or 62 millimeters, of steel. All of this armor was sourced from the German Navy Wattengrade naval plate, the same steel used on warships like the Scharnhorst. By 1944, Germany had essentially given up building large warships, leaving stockpiles of this steel sitting unused and available. German proving ground tests bore out just how tough it was. Plates between 7.87 and 9.84 inches, or 200 to 250 millimeters. Shrugged off 88 millimeters, armor-piercing rounds even fired from as close as 328 feet, or 100 meters. The hull itself was effectively built twice over, a fortress inside a fortress. What an enemy gunner saw was only the outer shell. Nested inside it sat a second, fully enclosed inner hull running almost the full length of the vehicle, with walls 3.23 inches, or 82 millimeters, thick. The gap between the two hulls housed the suspension and running gear. Any round that managed to punch through the outer side plate still had to defeat that inner wall before it could reach the crew, engine, or generators. Internally, the hull was split into 4 sections in a row: the driver's compartment up front, the engine bay behind it, the fighting compartment beneath the turret, and finally the transmission compartment at the rear. The plates themselves were joined using an interlocking welding method, and a single hull consumed 4,409 pounds, or 2,000 kilograms, of welding electrodes to assemble a third of it high alloy, steel loaded with nickel, chromium, and molybdenum, all scarce and costly materials by 1944. The Maus had originally been designed to run on a diesel engine, cheaper to operate, less prone to catching fire, and better suited to a vehicle this heavy. That engine, however, was never finished in time, forcing engineers to find a stopgap. The only option available was the Daimler-Benz MB509, a gasoline engine adapted from the DB603A aircraft engine. That engine had originally powered heavy combat aircraft, such as the Me-410 Hornet. It displaced 44.5 liters, or 11.76 gallons, and produced 1,375 horsepower at 2,300 revolutions per minute. Because of its aviation routes, it kept its inverted layout, with the crankshaft mounted at the top, which meant engineers had to route the power downward through extra gearing to reach the generators mounted below. It came with a mechanically driven supercharger and dual ignition, running 2 spark plugs per cylinder. A small Riedel Victoria RBA F10 two-stroke starter, rated at 10 horsepower, was used to spin the main engine over to get it running. Once turning, the MB509 drove the main generator set through a single reduction stage. That generator set was made up of 2 Siemens Schuckert units running at around 800 volts. Power from the generators then flowed to a pair of traction motors mounted at the rear, 1 motor for each track. The single strangest feature of the whole machine, and something we'll come back to shortly. Even with independent motors driving each track, the Maus remained painfully slow. Top speed topped out at just 12.4 miles per hour, or 20 kilometers per hour, barely half of what a King Tiger could manage, and off-road it typically crawled along at somewhere between 2.5 and 6.2 miles per hour, or 4 to 10 kilometers per hour. Fuel consumption was staggering. On roads it burned through 6 gallons per mile, or 1,400 liters per 100 kilometers, and that climbed to 16 gallons per mile, or 3,800 liters per 100 kilometers over rough terrain. To keep up with that appetite, the tank carried 3 separate fuel tanks. Two sat at the front of the hull, one on either side of the driver and radio operator, each holding 211 gallons, or 800 liters. A third tank, mounted externally behind the turret, added another 264 gallons, or 1,000 liters. All told, that gave the Maus 687 gallons, or 2,600 liters, of total fuel capacity, 3 times what a King Tiger could carry. Even so, its range was disappointing. On roads, it could cover about 116 miles, or 186 kilometers. And off-road that fell to just 42 miles, or 68 kilometers. Strip away the external tank, and that number dropped further still, down to only 26 miles, or 42 kilometers. Inside the engine bay, operating temperatures normally hovered around 160 degrees Fahrenheit, or 71 degrees Celsius. But under heavy load, they could climb as high as 320 degrees Fahrenheit, or 160 degrees Celsius, hot enough to fry an egg on the spot. The onboard Minimax fire suppression system was calibrated to trigger automatically at exactly that temperature. Controlling that much heat demanded a cooling system so large it occupied most of the available space inside the hull. Split across 2 separate circuits. The first circuit served the main engine. A pair of large fans pulled air through water and oil. Radiators, before venting it out through vents cut into the roof at the sides, those fans alone consumed somewhere between 120 and 148 horsepower straight out of the engine's output. The second circuit cooled the electrical drivetrain. A fan mounted on the generator shaft drew air across the generator, then through the transmission bay, where it picked up heat from the traction motors before finally exiting out the rear of the roof. Starting the engine could be done 2 different ways. The usual method relied on an auxiliary power unit paired with an electric starter, while a backup method used a small Riedel RBA F10 starter engine in case the main electrical system failed. Using the standard procedure, the driver first opened the main fuel cock, then flipped both battery master switches to on. He'd work a hand pump until fuel filled the lines and pressure registered on TH. E-gauge, push the ignition key forward and set the ignition selector to the M1+2 position. Next came the starter button on instrument panel 1. Once oil pressure was confirmed, he'd ease off the foot pedal and let the engine settle to an idle around 700 revolutions per minute. Steering was handled through 2 levers. Pushing both forward sent the tank straight ahead, and the further they moved from center, the faster it went. Pulling both back past neutral put the tank into reverse. To turn, the driver pushed one lever further forward than the other. And to spin the tank around on the spot, he'd push one lever forward while pulling the other back. 2 foot pedals operated disc brakes on each drive unit, doing double duty as both parking brakes and emergency brakes. Despite the vehicle's crushing weight, the crews who drove it apparently found it, in their own words, child's play. A tank this heavy presented a challenge nobody had really solved before. A conventional mechanical drivetrain simply would have been torn apart by the forces involved. The answer was an electric drive system. The MB509 turned the main generator to produce electricity, which then traveled by cable to 2 large traction motors mounted at the rear. Each motor powered 1 track on its own. Together, the 2 motors weighed more than 4 tons. Because each track had independent power, the driver could send one forward, while running the other in reverse, letting the tank pivot in place. The motors also doubled as brakes. When the driver eased off, they fed power back through the system to the main engine, which used its own internal friction to help slow the vehicle down. Power leaving each motor passed through reduction gearing before it ever reached the drive. Sprockets, with an intermediate gearbox cutting rotational speed while boosting torque. The final stage of torque multiplication was built directly into the sprockets themselves. Porsche worked alongside Skoda to design the suspension, which used bogies riding on conical springs. Each bogie carried 2 pairs of road wheels, along with 2 support rollers and a complete set. Weighed 1,763 pounds or 800 kilograms. Square rubber blocks acted as limit stops for the springs. 6 bogies were fitted per side, each one bolted to the hull on one edge and to the integral armored side skirt on the other, fully boxing in the running gear and shielding it from shell fragments and hits from lighter and medium caliber weapons. The drive sprockets sat 2.46 feet or 750 millimeters above the ground, engaging the track links to propel the vehicle forward. Skoda engineered a new track specifically for the Maus, 43.3 inches or 110 centimeters wide, with each track built from 112 individual links. Laid flat with no sag, the ground contact length measured 19 feet 3 inches or 5.86 meters. Under the tank's actual combat weight, though, the track sank about 3.9 inches or 9.9 centimeters into the ground, stretching that contact patch out to 23 feet 3 inches or 7.1 meters. In action, the Maus was best suited to fighting from a dug-in prepared position. Its greatest strength was simple. It could engage enemy armor from extreme range using a gun power Fu, enough to destroy virtually anything the Allies could put in front of it. A crew might sit near a tree line or along the edge of a defensive sector, watching open ground stretch out ahead of them. Once the commander spotted enemy tanks, he'd pick out the lead vehicle and call out the range, enemy tanks. Advancing at 11 o'clock, 1900 meters, the gunner would swing the turret onto the target while the two loaders worked the heavy two-piece rounds projectile in first cartridge case right behind it. Once loaded, the gunner made his final aim correction and fired. The 128mm gun carried more than enough power to destroy a T-34 85ths outright. The shell would cover the called distance in roughly 2 seconds, and if the range estimate was accurate, it would slam into the T-34's frontal armor and punch straight through. In a clean, long-range duel like that, the Maus held every advantage. But the trouble started right after that first shot. The crew then had to crank the breech open by hand and reload to separate pieces of ammunition before they could fire again. While that reload was happening, the rest of the Soviet force wouldn't just sit still. Tanks would fan out, duck behind terrain, and shift between covered positions. The Maus simply couldn't keep pace. It was too heavy to maneuver quickly, too slow to reposition, and far too large to hide once it had given away its location by firing. It might still be dangerous head-on, but it had no way to chase down enemy armor or pivot fast enough to face threats appearing from another direction. That opened up options for the enemy once Soviet forces knew exactly where a Maus was sitting. They could simply steer clear of its gun and instead call in artillery or aircraft. The Maus had no anti-aircraft armament of any kind to defend against that. Bombs striking the turret roof or the ventilation grills over the engine could immobilize the vehicle and kill the turret crew outright. In early 1945, the second prototype, the Maus V2, was moved toward the Zossen sector as part of Germany's collapsing final defenses. It broke down before ever reaching combat, and its own crew destroyed it rather than let it fall into enemy hands. Given its size, almost no bridge anywhere in Europe could bear the Maus's weight, so it needed a way to cross rivers entirely on its own. The engineer's answer was one of the more bizarre solutions ever fitted to a tank. Unassisted, it could wade through water up to 6 feet 7 inches or 2 meters deep. For anything deeper, it had to submerge completely with a maximum diving depth of 26 feet 2 inches or 8 meters. Getting ready to go under required the crew to seal the entire hull. Covers went over the ventilator openings, bolts sealed the gun, mantle it shut, and the machine. Gun was withdrawn with its opening plugged. Every hatch was closed and locked down, and the turret itself was lowered onto its ring and secured in place, tall enough to reach above the surface and feed air down into the sealed hull, held steady with supporting wires. To actually pull the sealed tank across the riverbed, a second Maus would idle on the near bank with its engine running. A heavy electrical cable connected that tank's generator to the traction motors of the submerged vehicle. In effect, the tank on the bank generated the electricity, while the tank underwater used that power to crawl its way across the bottom. Once the first tank reached the far shore, the two vehicles would swap roles so the second Maus could make the same crossing. The Maus stood as the purest expression of Germany's faith in thick armor and heavy firepower. But by 1944, German armored units were fighting a defensive, fluid war, needing to move fast and plug holes wherever the front line was collapsing. A 180-19 vehicle that couldn't even cross most bridges was never going to be useful for that kind of fighting. Albert Speer later remarked that nobody within the tank arm had actually wanted such a colossal vehicle built in the first place. Every single Maus ate up enough manufacturing capacity to have built 6 or 7 Tiger tanks instead. The engine alone cost 125,000 Reichsmarks, more than the 117,000 Reichsmarks it took to build an entire Panther tank from scratch. In the end, the Maus never became the superweapon it was meant to be. It was, quite simply, too heavy and far too slow. If you've noticed anything we got wrong, drop it in the comments below. We're always trying to do better. And if you'd like to see more, check out the link to our video on the King Tiger, a heavy tank that, unlike the Maus, actually made it onto the battlefield.